Good evening, everyone, and we're continuing with our distance learning. And today I hope to introduce water analysis to you. As you may already know, I sent you a lengthy email earlier today where I talked about the fact that we're going to have to scale down our water analysis project significantly because you're obviously not able to work in groups and collect water samples and test them yourself. But I still felt it was important to give you an appreciation of how such water testing can be accomplished. So the plan is for us to do an abbreviated version of the project where we will only be concentrating on one possible contaminant, which is nitrate. Typically we would do either nitrate or phosphate, but we're only looking at nitrate. And I'm going to explain to you how this analysis is accomplished. I'm going to show you some things. I'm going to discuss data acquisition and data analysis. And then later, in a couple of days, I'm going to send you some data, and hopefully you'll be able to analyze it and arrive at an amount or concentration of nitrate in some unknown samples. So I have a summary of the project right here. Like I already said, we're only looking at the procedure for testing for nitrate. This procedure can be used to test in either natural or drinking water, and it uses a device called nitrate ion selective electrode, typically abbreviated as ISC. Such device as nitrate ion selective electrode allows you to measure voltage or potential, usually expressed in millivolts, which develops across its membrane and is a function of concentration of a specific ion. In our case, of course, that ion is nitrate. Before we go any further and discuss how concentration of nitrate can be determined using ion selective electrode, I'd like to point out that nitrate is an extremely important substance. It's used in a variety of fertilizers. Well, it's not used directly. It's usually, fertilizer usually contains ammonia salts, and then ammonia is oxidized in nature and turns into nitrate. And nitrate can be detrimental to our health if we drink water with high concentrations of nitrate. Many negative health effects are possible. I gave you some information to read, so hopefully you read about what's called blue baby syndrome. This is when young babies who drink water rich in nitrate can develop oxygen deficiency, and their blood may not have enough oxygen in it, and then they turn blue and may possibly die. Nitrate also is related to certain stomach cancers and other illnesses. And so United States Environmental Protection Agency mandates that the amount of nitrate in drinking water cannot exceed 10 milligrams of nitrogen per liter. And we will later discuss a relationship between concentration expressed in milligrams of an ion per liter and parts per million. And what I wanted to show you real quick before we proceed further is the map that we would typically use to select samples that we would be collecting and analyzing. We typically look at natural water from such sources as rivers, lakes, ponds, and streams. And this map over here that I would like to show you briefly, it's also posted on Canvas for you, shows 3 rivers in the area where BGSU is located. And many of you may be familiar with these rivers depending where you're from. This river here is the biggest river in the area, longest, and has the biggest watershed. It's of course Maumee River. You only can see here a portion of its watershed. It actually starts in Indiana near Fort Wayne, flows northward through places like Waterville, Maumee, Perrysburg, and then flows into Lake Erie near Toledo. This here is more of a creek Then a river it's called Toussaint Creek, and as you can see, it also flows northward. It does flow through BG, and also flows into Lake Erie. And then lastly, this river, southernmost river on this map, is called Portage River. Also flows northward, also flows into Lake Erie near Port Clinton, flows through such towns as Portage, Pemberville, and Woodville. Does not flow directly through Bowling Green. It's a little south of BG. The importance of this map is, of course, the fact that all three rivers here and multiple other rivers in Northwest Ohio and Ohio in general flow through a lot of agricultural land where there's a lot of possibility of them to pick up contaminants, including nitrogen-containing compounds, nitrates, and then carrying all those pollutants, all those contaminants into Lake Erie. And Lake Erie, of course, is used as one of the biggest reservoirs of fresh water. So quality of water in the rivers, as well as in the lake, is of utmost importance, not only for humans who consume the water, but also for animals and fish that live in it. In our area, concentrations of nitrate can be routinely high because, again, it is a highly agricultural area. There are some ways to reduce amount of nitrate in natural water, such as planting trees and bushes on river banks that eliminates or minimizes the amount of runoff. Of course, educating farmers about proper practices for fertilizer application. As far as drinking water, I asked you to look at Consumer Confidence Report published by City of Bowling Green. There's a table that looks something like this. It's not of very good quality here, but this table can be found on City of Bowling Green website, and I would encourage you, since you're home right now, to take a look at your local municipality and see what kind of information they provide for drinking water quality. Nitrate is listed here under inorganic contaminants, and it does say that maximum allowable concentration of drinking water is 10 parts per million for nitrate. And the Consumer Confidence Report will tell you in pretty much any locality, not just in Bowling Green, what they're doing to minimize the amount of nitrate. I would like to point out that nitrate is a very small particle. It's an ion that cannot be filtered out. So if you have something like Brita filter at your house or apartment, it will not remove nitrate. And sometimes people falsely think that it would, but it doesn't, because nitrate, again, is too small. And the only way to effectively remove nitrate from water is a process called reverse osmosis, which in Bowling Green they started installing reverse osmosis devices probably about 5 years ago. And it may vary with locality, so I encourage you to do some investigating and find out what your water is like in your area and how they treat the water as far as nitrate is concerned. So now we're going to switch our attention to the way we look for nitrate. We already mentioned using ion selective electrode, or ISE, for this purpose. ISE has a special membrane on its bottom. I will show you the electrode and I will show you the measurement shortly. The membrane develops voltage across it because concentration of nitrate inside the electrode and concentration of nitrate in the solution it's placed in may be different. So what we measure is voltage or potential. It's expressed as E. And this voltage or potential is actually related to the log of the concentration of the ion. this equation, which you will cover with Dr. Glasson lecture towards the end of the semester, is called Nernst equation. Nernst equation says that voltage is equal to constant, that expresses standard voltage minus another constant, K times log. This is log with a base of 10 of nitrate concentration. This is an important equation that is provided in the write-up of the procedure that's posted on Canvas for you. It's procedure part 2, where this equation is discussed. What I'd like to point out here is how concentration change would be related to voltage change. Let's take a look at this. Notice the negative sign in front of K times log of concentration. So what would happen if concentration of nitrate increased? Well, if concentration of nitrate increased, log of concentration would also increase. But then we would be subtracting it from our constant here, giving us smaller value. In other words, the higher the concentration of nitrate, because there is a negative sign right here, the voltage would be expected to become lower and lower. And we're going to take a look at some data a little later and see how that's related. In this abbreviated project, I wanted to give you a summary of what you may expect to happen. So I'm going to discuss how we can start by preparing a stock solution containing known desired concentration of nitrate. Then how we can use this stock solution to prepare several, specifically 4 standard solutions of nitrate, each having its own desired concentration, and then measuring voltages of each of the standards, and using these voltages of the standards to prepare a calibration graph, which would show us a relationship between log of concentration and voltage, and then measuring voltages of 2 solutions. One would be an unknown. It's something that I give students to use in the lab that has a concentration of nitrate that I know but students don't. And by measuring voltage and using the calibration graph, students can find out what the concentration is. And then I thought we could also measure voltage of tap water here in the lab, so that you can use it as sort of a second unknown and find out what nitrate concentration is here in this lab in Moseley Hall. So this will be the summary of this project that we're trying to accomplish via distance learning. So I will be sending you data regarding concentration of stock. You will have to calculate concentration of standards, and then I will also give you data for voltages for the standards, so you can make your own calibration graph. And then I'll give you voltages for the 2 solutions, one of which is not a solution, it's tap water, and the other one is an unknown solution. So that's the summary of the project. We're done for now. Thank you.